I apologize, for current and voltage division, you can't use more than 2 resistors, right?
Right. You want to do two at a
Right,
time.
right.
You want to do two at a time. Okay. So here we have to find the voltage drop across each resistor. So we are going to practice some of the stuff that we've been talking about. So the first thing let's do is let's figure out what the current is coming out of the voltage source. And to do that, we want to do what we did in the problem just a minute ago, and that is simplify all this stuff to where we can get down to one equivalent resistor. So this first one here, R1 parallel to R2, so R1 parallel to R2 is 3.3 times 6.2 over 3.3 plus 6.2, which is 2.154 kiloohms. So don't forget to pay attention to the kiloohms on some of those. And then we come down here to R3, that's 1 kiloohm. And now I'm going to go ahead and combine these two that are in series over here and say that that one is it's 1070 ohms, which is the same as 1.070 kiloohms, to keep it in the same units since everybody else was in kiloohms. So now I have 1 kiloohm here, and I have 1.070 kiloohms here. And now I have 1 kiloohm. Now these are in parallel, so I can use product over sum. So this is 1 times 1.07 over 1 plus 1.07, which is 0.5169 kiloohms. And now I have 3 resistors in series, so I can just add those together. So 2.154 plus 1 plus 0.5169, I get 3.6709 kiloohms. And this in the problem was given to be 8 volts. So now I can find the current coming out of the voltage source. So I equals V over R, or I equals 8 over 3.6709 kiloohms. And if I just leave the kilo in there, that means my answer is going to be milli. So without multiplying by 1,000, I just know I can say when I get this number, that's going to be milliamps.
What did you get for 1 times 1.07 over 1 plus
0.5169.
And did you convert it to kiloohms?
I did that at the very first step when I added these ohms together and got 1070 ohms. I changed it right then to 1.070, so everything is now in kiloohms.
Okay.
And then, like I said, now when I do this division, I know I'm going to get milliamps. So this is I is 2.179 milliamps. Okay, so now we are supposed to get the voltage drop across each resistor. Now something comes into play that we were just talking about that's really helpful.
Those two top ones would have the same voltage, right?
That's right. These two top ones have the same voltage drop because they are in parallel. So we can find the voltage drop across their equivalent one, and that's the same as what they'll have there.
Okay.
So I can use this one, that right there, and the entire current, my entire I, is going across that equivalent resistance. Now, when it comes up here, it's going to split. Some will come here and some will come here. And then I would have to do the I times R, the different I times the different R for each one of them. But I know that I would get exactly the same as if I take the total I times the equivalent resistance. So V1 equals V2 equals 2.179 milliamps times 2.154 kilo ohms, and the milli and the kilo cancel each other out, and I'll end up with just volts, which is 4.69 volts. Okay, now once the current has split up and gone through these two resistors, it comes back together. And when we're on this side of that, we're back to having our entire current again. And so going through R3 is our entire current of 2.179 milliamps. So to find the voltage drop for R3, it's 2.179 milliamps times 1 kilo ohm, which will be 2.179 volts. Okay, so now what we can do, because I'm just lazy. I want to do things as lazily as I can. So I start with 8 volts. I've lost some here. I lost 4.69. I lost 2.179 going across this. The rest of it I have to lose going across this. So I know that I started with 8 and then minus, so V4, so the voltage across V4 is the same as the voltage across R5 and R6 together, which is the same across as the voltage across their equivalent resistance, but rather than doing a V equals IR again, which I could, I'm just going to say that V4 equals 8 minus 4.69 minus 2.179, and I get that V4 equals 1.125. Okay, so now this is R5, and we have V5 is 1.125.
You said V4 and V5 are equivalent, so you said 1.145?
1.125. I did not say that V4 and V5 are equivalent. I said V4 is equivalent to the total across R5 and R6. Okay, and that's what we're going to use right now. So we know the total across, this is R4, the total across R5 and R6 is 1.125. This was 680 ohms. This was 390 ohms. And this is R5, and this is R6. So V5 equals the total voltage drop, 1.125, times 680 over 680 plus 390, which equals 0.716. Now, I could do the same thing and do a voltage division to find the voltage across R6, or I can say that V6 is going to be 1.125 minus 0.716, which is 0.409.
You said V5, or sorry, V5 is 1.125 times 680 over 1070? Because that's the. Okay, I got something different. Hold on. I may have.
Did I say 680
Yeah, I was about to
over?
ask you, should it be 390 instead of, it should be 390 over?
I think I did something wrong. I think you're fine.
Cause
Yeah, I did something wrong. That was on me.
Okay.
Yeah.